Every year, millions of metal tools reach the end of their working lives. Wrenches worn smooth, cracked, and rusted beyond use, piling up in workshops, junkyards, and scrapyards. To most people, they are nothing more than waste. But to one of the most advanced steel recycling facilities in the world, these discarded wrenches are not the end of a story. They are the beginning of one. Because every single wrench you are about to see will leave this factory as something completely different. A solid, deformed steel bar, 12 millimeters in diameter, ready to reinforce the concrete foundations of buildings, bridges, and roads around the world. The process begins at the scrapyard, where mountains of rusted wrenches are collected from workshops, automotive repair centers, and industrial recycling programs. These tools are made from high-quality chrome vanadium, or chrome molybdenum alloy steel, extremely dense and durable, which is exactly what makes them valuable as recycled raw material. A massive excavator fitted with a hydraulic claw moves steadily through the pile, lifting heavy loads of wrenches and dropping them into a receiving hopper, beginning the journey into the factory. Before any material enters production, it passes through a sorting and inspection line. Workers and automated magnetic separators remove non-metallic debris, rubber grips, and any contamination that does not belong. Every piece of scrap entering the process must be pure, ferrous metal. The cleaner the input, the higher the quality of steel that comes out the other end. From sorting, the wrenches move into a high-pressure washing station. Powerful jets of pressurized water blast across every surface, stripping away rust, oil, grease, and accumulated grime. The dark, contaminated runoff drains away through sealed collection channels, while the wrenches emerge cleaner and ready for the next stage. This step is not cosmetic. Impurities left on the metal surface can introduce unwanted elements into the melt, potentially weakening the final steel product. The cleaned wrenches then enter an industrial shredder. Inside this machine, massive rotating blades tear through solid metal tool after tool, reducing entire wrenches to jagged steel fragments within seconds. The shredded pieces tumble onto a discharge conveyor and pass through a secondary crusher, which compacts them into a more uniform fragment size. By the time the material leaves the crushing stage, nothing resembling a wrench remains. What enters as recognizable tools exits as a dense stream of raw steel fragments, ready for the furnace. These fragments are lifted by conveyor and charged directly into an electric arc furnace, one of the most powerful pieces of equipment in modern steelmaking. Inside this furnace, enormous electrodes generate an electric arc that reaches temperatures far exceeding the melting point of steel. The fragments liquefy rapidly, collapsing into a glowing pool of molten metal. But this is where the process becomes genuinely precise. Wrench steel carries a high alloy content, chromium, vanadium, carbon, elements that make tools strong but would make structural rebar brittle if left uncorrected. Furnace metallurgists add carefully calculated amounts of iron dilutants and chemical agents to the melt, adjusting the composition until the molten metal matches the exact specification required for structural grade steel. Samples of the melt are drawn and tested in the on-site laboratory, confirming that carbon content, manganese levels, and other key properties fall within the strict tolerances set by structural steel standards. Once the composition is verified and approved, the furnace tilts and releases a brilliant stream of molten steel into a ladle. From the ladle, the steel is poured into a continuous casting machine, where it flows into a series of water-cooled molds. As the steel passes through these molds, it solidifies rapidly from the outside in, forming a long, continuous billet, a rectangular cross-section of solid steel that still glows intensely from the heat retained within its core. This glowing billet is cut into working lengths and transferred immediately to the rolling mill while still at high temperature, since reheating would waste energy and compromise the steel's internal structure. Inside the rolling mill, the billet passes through a carefully sequenced series of roll stands, each one applying precisely controlled pressure to stretch, compress, and reshape the metal. With every pass, the billet narrows and elongates. At the same time, specially shaped rollers begin to press the characteristic raised deformations, the ribs and lugs that define a deformed steel rebar into the bar's surface. These deformations are not decorative. They are engineered to lock mechanically with concrete, dramatically increasing the tensile strength of reinforced structures. As the bar exits the final rolling stand, it has been transformed into a continuous deformed steel bar, measuring exactly 12 millimeters in diameter along its entire length. Still glowing from the rolling process, it moves into a water quenching system, where controlled jets of water rapidly cool the bar's outer surface, a process that strengthens the steel's surface layer while leaving a slightly softer, more ductile core. This combination of a hard surface and a flexible core is precisely what makes 12mm rebar perform so well under the compression and tension forces it will experience inside reinforced concrete structures. From quenching, the cooled bars move into an automated cutting station, where rotating blades slice them into standard commercial lengths with remarkable precision. Each cut bar is then visually inspected and passed through a final dimensional check, confirming that diameter, rib pattern, and length all meet the required structural specifications. Any bar that does not pass this check is immediately removed and recycled back into the process. Approved bars are gathered by robotic handling systems and bundled into uniform stacks, then secured tightly with steel strapping for transport. Forklifts carry the finished bundles into the warehouse, where they join rows of identical product organized by diameter and length, ready for shipment to construction sites, distributors, and concrete manufacturers who will use them to reinforce the structures that hold our built world together. What began as a pile of discarded, rusted wrenches, tools that had served their purpose and been thrown away, has become something structurally essential. Every wrench that entered this factory was completely transformed, not just in shape, but in composition and purpose. That is the extraordinary power of modern steel recycling. Nothing is truly wasted. The tools of yesterday become the foundations of tomorrow.
All right, bring it down slow. Watch the edge. Easy now, easy.